Here we are with CCNA 4, Chapter 4, Access Control Lists. This is a long set of slides. Probably going to get through them as quickly as I can. Because why? We've already went through standard access control lists in CCNA 2, so there's a little bit of review here, but we will be moving on to extended IPv4 and IPv6 access control lists, as well as troubleshooting them. Access control lists are going to come into play as we go into the subsequent chapters in CCNA 4. So want to know these pretty well because it's going to affect other topics where we'll configure this, that, and the other. All right. So standard access control list operation. Again, we've done a little bit of this in CCNA 2. So if you remember, access control lists are a sequence of permit and deny statements. Permitting this, denying that. With standard access control lists, we can only permit or deny based on source IP address. As we get into extended, we can permit or deny based on source IP address, destination IP address, the protocol being used, and the port number, which also is associated with the protocol. So you'll see things get a little bit more complicated as we get into as we get into extended access control lists. As a packet passes through a router with access control list, or traffic does, the router is going to configure information in each packet against the access control entries in the list. So we have access control entries that make up the access control list. And if it matches, the first item that it matches, it's going to use. So if the first item that matches your network or the contents of the packet is a permit, it's going to permit and stop checking. If it's a deny, it's going to deny and stop checking. That's how the access control list works. Also use a wildcard mask. We've discussed wildcard masks before. It's basically the inverse of a subnet mask. I'm not going to spend much time on that because we've discussed it quite a bit. Basically, if you want to match a network, with your wildcard mask, that is, just take your normal subnet mask and take all 255s and subtract your subnet mask. You'll get the wildcard mask. I think we saw that just recently, if I'm not mistaken. If not, you can take a look at CCNA 2. It's in there. Again, to get a wildcard mask, you're just going to take all 255s, subtract a subnet mask, and you'll get the wildcard mask. Let me see if there's a graphic that I can show you for that. Well, there isn't a graphic that I can show you, but I can try to explain it. So this wildcard mask is 0.0.0.255. How we would get this wildcard mask is from a subnet mask of 255.255.255.0. Okay, because if you take all 255s, like you see here, and you take 255 minus 255, you get 0. 255 minus another 2.5, you would get 0 there, the second 0. 255 minus 255, you would get this third 0. Then if you took 255 minus 0, you would get 255. So again, for this entry, the subnet mask that matches that is 255.255.255.0. Okay, so again, if you take all 255s, subtract the subnet mask, you will get your wildcard mask. Okay, that's if you want to check that out, that's in my CCNA 2 videos. It's in the CCNA 2 chapters, so check that out. Okay, inbound ACLs and outbound ACLs. You can have a ACL that's checked as a packet comes in to the router, or a ACL that checks the packet before it exits the router. In certain situations, it's going to be appropriate to use one or the other. If you can, if it will work for the access control list you've got set up, inbound is better in that it doesn't go take the packet and send it through the routing table before it checks the ACL. So you can save your router some processing time if you can put a access control list on the inbound interface. But that's not always an option. Sometimes there's an inbound packet and there's multiple outbound interfaces, and you want traffic to be able to go out maybe two interfaces, but not another. If you stopped the traffic here, it wouldn't go out any of the interfaces. So you want to be careful where you place your ACL, and that'll come up more as we go through the chapter. Move forward. So as far as applying ACL's rules for them, you can have one per protocol, one per direction, one per interface. So your example that you see here says you have a total of 8 separate ACLs you could apply. Okay, why? Why is that? Because you have one interface. We'll say this is Gigabit Ethernet 00, this is 01. Okay, you can have a IPv4 inbound ACL and an IPv4 outbound ACL on one interface. You can have an IPv6 inbound and an IPv6 outbound on that interface as well. One per protocol, per direction, per interface. Okay, so that makes a total of 4. IP in, IPv4 in, IPv4 out, IPv6 in, IPv6 out. That's 4. Okay, we have another interface that can do the same thing. That gives us 8. All right, 1 ACL per protocol, 1 per direction, 1 per interface. Okay, hopefully that makes sense. All right, inbound, outbound for IPv4, inbound, outbound for IPv6. That makes 4 and another 4 here. Okay, hopefully that's okay. This again is more review, the TCP conversation, how it gets started, how it transmits data, and how it finishes. You've got your sync, synchronization. Hey, let's talk. Sure, let's talk. Acknowledging the SYN. And then after this guy acknowledges, great, we have a connection, sends an acknowledgement back. After it sends an acknowledgement back, to establish the connection, we've got data that starts being transmitted. I need to send you some data. Okay, I acknowledge that I've received your I'm sorry, it's saying I need you to send me some data. Thanks, I've received your request. Here's the data you want. Okay, data sent. Acknowledgement of that data being received. Thanks, I've received my data. I'm finished. I don't have any more data to send. Okay, I'm finished as well. I acknowledge that you're finished. Blah, blah, blah. Done. Okay. It could also request more data if it needed more data before closing out the session. So it doesn't have to be that short. That's as basic kind of as it gets when you're talking about a TCP conversation. Okay, you establish connection, you terminate connection, that's TCP. Remember, UDP is kind of the opposite. It just sends stuff along the way. So TCP is stateful, UDP is stateless. The TCP data segment also identifies which port matches the requested service. Those port numbers are going to become important depending on what you decide to use. When we start making extended ACLs, you can either use the acronym for a protocol or you can use a port number when setting up your extended ACLs. So it's going to be up to you what you want to use. Either one will be acceptable. So, packet filtering controls access to a network by analyzing the incoming and outgoing packets and forwarding them or discarding them based on the given criteria. Again, that can be multiple things, that criteria. If it's standard, it's just going to ask what network it's from. If it's an extended access control list, it's going to ask a little bit more. What services is it asking for in particular? Also a destination network and extended ACL. So it asks first, if it's a standard, which network is it from? Okay, then it would permit or deny based on a standard access control list. If it's an extended one, which gives you more flexibility, then it'll ask what service or port you're using. Okay, port 80 is HTTP, so if it's for HTTP, if it's from network A, it'll allow it. But in this access control list, there is an entry that says if it's from network B, okay, and it's asking for a service on port 80, you deny it. Okay. If it's not looking for port 80, you'd allow it in this situation. If that doesn't make much sense, it will after the next 50 slides. So at least hopefully, we'll see. So here we are, the breakdown. Standard access control list, which we configured in CCNA 2, can only permit or deny based on the source IP address. Okay, destination of the packet and ports are not involved, not evaluated in standard, but in extended they are. So you can have the protocol type, source, destination IP, source TCP or UDP ports, destination TCP or UDP ports. Okay. Optional protocol type information for finer control. So you can use all of those things in extended, and we'll go through plenty of examples, or at least a few, that show you how the extended versus standard differ. So here are a couple examples of numbered access control lists. You've got just one entry per list. You've got access list 10, permit the 192.168.30.0 network with a wildcard mask of 0.0.0.255. Okay, which means that's going to affect everything in that 30.0 through 30.255 range. Okay, because the subnet mask that goes with this wildcard mask is 255.255.255.0. All right, so this is the source IP address of the network. That's all it will filter on for that access control list. The extended is going to be a little different. We've got access control list 103. Okay, and the reason we're at 103 is because anything over 100, that's extended ACL. 1 through 99 is going to be a standard ACL. Okay, you've got your protocol type, TCP. TCP is going to be what comes up here in most situations, I would say. But that is your protocol type. Then you've got your source IP address or source network. Okay. Then you've got the destination. That's what this any is. You can use any, and also you can use host that you'll see a little bit later when you're creating these access control lists. Okay. So any means, let me go this back up. This is the source IP address range. Okay, 192.168.30.0 with the same thing as up here, 0.0.0.255. Destination could be any network. That's what this is saying. Okay, so any packet with a source IP within this range. Destination doesn't matter anywhere. And then the protocol 80, port number 80 equal to 80. That means HTTP for that particular network heading for anywhere is going to be permitted. Okay, so again, we're permitting TCP from this network to any network that is using HTTP. We're going to be permitting that traffic. Hopefully that makes sense. Okay, we'll see. All right, we're going to talk about named versus numbered ACLs as we go through here. But like I just said in the last slide, your standard ACLs are going to be 1 to 99. Then you've got 1300 to 1999. And your extended are going to be 100 to 199. Okay. Yeah, that's pretty much it there. The named ones are going to be written alphanumerically. They can be written in, it suggests they be written in capital letters. I'm just going to make them stand out a little bit more. Cannot contain spaces. Entries can be added or deleted within the ACL a lot easier in a named ACL. Okay. When you're using a numbered one, you have to always say access list the number, permit, access list the number, permit, access list the number, deny. So you're writing access list then the number over and over and over and over again. Okay. If you create a named one, you're just going to have to write access list, we'll say standard or extended. That's how you determine whether the name's going to be standard or extended access list. Then we could say HTTP. Okay, so once again, I'd say access list standard HTTP, and that would be my name for it. I press enter, then it takes me to a different prompt, and I can just make permit and deny statements without having to type access list over and over again. Okay, you'll see that a little bit better when we start configuring it. I probably shouldn't even have stuck that there, so you'll see that in action in just a moment. All right, where do you want to place your ACLs? You want to place your standard ACLs near the destination, and you want to place your extended near the source. Okay, I'm going to explain that on this slide. I see it on the next slide that I think there's some text, but we can just do it here. So why would we do such a thing? So standard ACLs only filter based on the source IP address. Let's say there's traffic coming from this 10 network. Okay. If I place a ACL denying traffic from that network, remember I can't deny based on protocol. All I can deny based upon is source IP address. If I place it here, a deny outbound, it's never going to leave R1 up to R2. Okay, it can go down to this network here, the 11 network, but it will never go out that direction. And let's say my intention is just to block PC1 from having access to this server over here. Well, I'm going to block it from having access to multiple places if I place the access control list close to PC1. If I do it as far away as possible, which would be outbound on R3 on this link here, hopefully you're seeing that on this link here, okay, then I am just blocking its access to the server. I can still come into R3, go out G00 and get to the 30.12 network fine, but I can't get here because I've placed it as far away from the source as possible, or closest to the destination. Okay. With an extended, I can say that I'm going to deny any traffic from this network headed to that network. Okay, I can make that rule in extended ACLs. I can make that entry. So I can then place the access control list right here inbound on G00, which is going to free up my network as much as possible because it's going to check against that ACL before R1 even has to make a routing decision. That traffic will be killed right here. It won't be sent out to any other routers. So I'm freeing up my network, making things more efficient because I'm killing it right before it really has a chance to even enter the network at all. Okay. And again, I can do that because extended ACLs allow me to create that access control entry that says deny any traffic to here. Whoops, deny any traffic to there. All right, traffic headed to this network still would be fine. It'd be routed. Traffic to the 30.12 network would still be routed because all I'm filtering out is traffic with a source IP of this and the destination IP of that network. Okay, so extended as close to the source as possible. Standard is close to the destination. Standard, destination, extended, source, ES, SD. How do you want to remember that? I don't know. Okay. So extended source, destination, standard, destination. And what I just discussed is basically what they're saying here as to why you would put the standard close in the standard close to the destination, extended close to the source. This example is going to be similar to the example I just gave you with the standard ACL, showing you why you want to place it as close to the destination as possible. I'm just going to skip over that. We already went through that. So an extended, I went through an example of that. Hopefully that made sense to you. I'm going to skip through this as well. And here we have an example of standard access list configuration. Basically, it's access list, some number, if we're using a numbered access list, that is, between 1 and 99. Then deny, permit, or remark. Okay, remark is just a note to yourself, basically. If you need to explain something to yourself about what the access list is doing, you can use the remark for that. But usually you're just using a permit or deny. Okay, so these are some examples. Access list 10, permit, yada yada. Traffic from that source address. Okay. And if you do your show access list, you'll see that that entry is created. All right. If you don't want an access list 10, do no access list 10. That'll take it away. All right. Access list 10 remark, permit host from blah network. So the remark is just a note that you would see there in the access list. It doesn't do anything. It doesn't do anything at all. It's just a note that you're writing there. Okay. Then if we go to access list 10, create that same statement again. And if you did a show running config, include access list 10, or even show access lists would work too. You'll see that remark that you wrote, kind of reminding yourself what you created that access list for, and then the actual access list entry that you have there. Okay. And applying that access list to a interface. Again, they're just creating an access list here. All right. We already created one on the previous slide. This slide is assuming that no access list was created beforehand, so they create it. Okay. Then go to the interface, IP access group 1. So we're on S000, by the way. IP access group 1, and do you want it inbound or outbound? Out for out, in for inbound. So traffic outbound from S000 would permit this network. Okay, they haven't talked about it yet, but when you create an access list, there is an implicit deny at the end. So if you permit something, everything else is denied. So in this situation, only traffic from this network is going to be allowed out of S000. Every other network is going to be stuck down here. They can communicate from this side to that side. They're the only network that can communicate out S000 is going to be the one that's permitted down here. Because whenever you make a permit statement or an access list, there is a invisible entry at the bottom that basically denies all other traffic. It's called an implicit deny. Okay. Configuring a named list, you've got IP access list, and then you're going to determine whether it's going to be a standard or extended access list. Then you give it a name and press enter. Okay, that'll take you into this prompt here, config if standard named access list in this situation. Okay, so this one's a standard one. You can do your permit, whatever network, and press enter. Deny whatever network, press enter. You're going to keep on making your permit and deny statements from this prompt here until you're done. And you just would exit that prompt to move backwards to the left into global config again. Okay. Once you're done, creating that named access list, then you would do your access group and assign it to an interface. This is what it's going to look like. Okay, so in this situation, we've got IP access list standard, no access. Remember, you can't have any spaces, so that's why they have the underscore here. Okay, it's going to deny host, just means that IP address. So I mentioned host before. So if you go deny host 192.168.111.255, basically this host is like having a wildcard mask of all zeros. Okay, it's like having a wildcard mask of all zeros, which means it matches this IP address only. There's not a range here, it's just this host. Okay, so it would be just this computer here that is being denied. All right, permit anything else. So that's what this access list does. It gives no access to this PC2 here, which is 192.168.11.10. This IP address down here permits anything else, any other IP address. And you exit. Then go to your interface, IP access group, no access, out, the name of the group that is, or the name of the list, IP access group, no access, out. Okay, we're at G00, so anything going this direction, okay, it's going to be caught. So basically this computer here is not going to be able to communicate with anything over here at the left side of our topology. All right, and away we go. How do we verify our access list? You can do show IP interface, and then whatever interface you want to take a look at, you'll see the outgoing access list. Access list is 1. There's no inbound. If we look at the G00, you can see that the outgoing access list is no access. That named access list we just saw. So you also got show access list, which will show you exactly what went into creating these access lists. Okay. I think we'll get into modifying them soon enough, but these numbers out here become important when modifying. Extended. And things get a little bit more complicated. All right, we already talked about this. Blah. Yes, we know what a standard extended access list can do. So as I was stating before, when you make your extended access list, you can filter by the port number of a protocol, okay, or the keyword like telnet, FTP, FTP data. These all match up with these numbers up here. So you can use one or the other, and really one's no better than the other. Whatever you are more comfortable with, or your company ends up deciding that they want to use, that's what you will use. As long as you know the general setup of it, it shouldn't be hard to switch between one or the other. All right. Again, we have an example of how it's set up. We've talked about that. We'll take a look at how it's actually implemented. So what are we trying to do with this access list? We've got access list 103 that we're creating. Okay, it's going to permit the 10 network HTTP, okay, or port 80. It's also going to permit the 10 network for 443, which is HTTPS. So it's going to prevent both of those from the 10 network here. That's all it's going to permit. Remember, at the end of the statement is an implicit deny. Okay. Then access list 104 allows, let's see, allows any source destination to get to that 10 network from an established connection. So the TCP section has to be established. You have to have requested information in order to get traffic back. Okay, so it has to be an established connection with this established command. We haven't seen that yet, but that's what this means. A session has to be set up by the device within this network, and if it has been established and you're getting information back, then traffic is allowed. If it's a device trying to communicate without an established session, then that traffic will be filtered out and it will fail. Okay. So where will we place these? You only want to allow from the 10 network. This is our network, 10 network down here. It's going to be allowed HTTP and HTTPS. So you can put that inbound on R1. Okay. Traffic from this network inbound on R1. Only thing that's going to be pushed through is HTTP and HTTPS traffic. All right. Anything else is going to be dropped. For this guy here, that is only going to permit traffic that is established from the 10.0 network back in. So you would put that as close to this guy as possible, which would be an outbound on this one back to the 10 network. So it's only going to allow established traffic back into the 10 network. Okay, only HTTP and HTTPS out. I'm sorry, I'm making that confusing. It's the HTTP and HTTPS is in because it's going into the router and then going over this way. Then coming back, this is an outbound, considering outbound going back towards the 10 network, that would only allow that established traffic to go that away. That away. Okay. So inbound on an R1 is going that direction. Outbound would be going this direction. If we're talking G00 here. All right, hopefully that's not too confusing. You can see the directions there. You can see the in and out. Hopefully that makes sense. Let's see, so what are we trying to establish here? We've got access list 101 deny TCP, source network of this, destination network, source network of 11, destination network of 10, FTP. So any packet that has a source network of 11, destination network of 10, we're denying FTP. So we do not want to allow FTP from this network here over to that network there. Okay. Also, we're going to permit anything else. Permit access list 101, still same 101, IP, any. Okay, IP, any. So any IP traffic is going to permit. All right. We can place that access list here inbound on R1, so G01 inbound, so that FTP traffic will be killed before it even gets checked against the routing table if you're trying to FTP over here to the 10 network. But IP traffic headed anywhere else will be fine because we have this IP any entry down here. Okay. Makes sense? Maybe, hopefully. We have another one. Let's see if there's anything really different here. Really, this is very similar to the one we just did with the numbered group, but this is going to be named. So you can see how the named is going to go. Again, IP access list extended surfing. So you named it. Your prompt here changes. Then you can just make your permit statements. Exit. Same thing here. You got a browsing one. Okay. Make your permit statement, exit, go to the interface and configure those named access control lists where they need to go. Okay, I'm not going to dwell there because this is going to get really long really quickly. All right, the show access list again, the show IP interface to show you where the outbound and inbound what the outbound and inbound access list is. You can see how that access list is made up. Editing, extended ACLs. You can use a text editor. You don't want to have to do that. You're going to use the sequence numbers. You could copy and paste your whole ACL into a Notepad or Notepad Plus, but that's going to be annoying. You would basically copy it into Notepad, delete the entire ACL, and recreate the ACL by pasting it back into your device and pressing enter. You don't want to have to do that. Sequence number is going to be a little bit easier. When you look at the access list created, there are sequence numbers out front, 10, 20. Okay, so if you wanted to place something before the 10, you could go 05. If you want to place it between these two, you could go 15. You can use that sequence number to edit the access list. Or you could say no 10 if you want to get rid of 10, for instance. No 20 if you wanted to get rid of this 20. And you'll see that in just a second. So you've got this that should be 10.0 instead of 11.0. Okay, so you can go into that named access control list in surfing, say no 10, that gets rid of this 10 entry. Then you can go ahead and type 10 over again, permit, blah, make your correction, end. When you show your access list again, it should be set up correctly. You should be good to go. That's how it's going to be. That's how it's going to go. That's about it. All right. Hopefully that makes sense. It's a lot better than having to go into Notepad, copy and paste everything. So we move on to IPv6 ACLs. These are going to be not limiting, but a little different from your IPv4 in that IPv6 ACLs, they are not numbered. They are not standard. They're only named and extended, okay? Or at least similar in functionality to extended. Okay. All right, so what happens here? What happens here? Your IPv6 is pretty similar to the extended IPv4 ACLs. It does use IPv6 traffic filter instead of access group that you would use in IPv4. Also, something that wasn't mentioned in IPv4 is there is an access class command when you're going to apply a access list to a virtual line, a VTY line. So remember that. I don't know why they forgot that here, but in IPv4 there is an access class instead of access group command if you're applying a access list to a virtual line, to a VTY line. Okay, here in IPv6 we've got IPv6 traffic filter instead of access group. Okay, no wildcard masks, use the prefix. Okay, and there's additional default statements. I talked about the implicit deny any that appears in IPv4. That's still there in IPv6. You're going to have a deny any at the bottom, but you're also going to have a permit for neighbor discovery, neighbor advertisements, and neighbor discovery, neighbor solicitation. Remember, this is very similar to the ARP process for IPv6, getting those MAC addresses. So this needs to be permitted. So that is there in your access control list by default. You don't type that. It's just there. Okay, but that is a question that could come up on the test. What additional statements are in IPv6? It would be that neighbor discovery, neighbor advertisement, neighbor solicitation, NS that show up. All right, here's the topology. It looks like we're going to work with. All right, and we've got IP access list, IPv6 access list name. Remember in IPv4 you had to put IP access list name, standard then the name, or extended then the name. Since there is no option between standard and extended in IPv6, it's IPv6 access list then the name. Okay, then follow it with your permit or deny statements and return to exec mode so we can take a look at how that's going to work. So here's a pretty basic IPv6 access list entry. We're going to make one that says no R3 LAN access. So it's going to deny, if you got IPv6 access list in the name. Okay, deny IPv6 2001 DBA CAFE 30::64. That's the source IP to any destination. Okay, you're just going to deny that to any destination. Otherwise, we're going to permit any other traffic. So we're basically just denying traffic from this this network and ending. All right. If we want to apply that, where is that network? The 30 network. It's right over here. Okay, it looks like that's the 30 network, right? It is. Let's go ahead and go further then. I think this slide may be a little off because we're denying traffic from R3. So if we want to deny this network, we should, if we're just looking to deny the 30 network, do an inbound here. And if we were looking to deny R3 any access to R2 or beyond, you should do it either outbound on R3 or inbound R2. It would be an outbound on R3 if we're following the rules, but they put that over here for some reason. I'm not sure why. It's not following our normal rules, so I think this slide is a mistake. Okay, we'll just go on from here. All right, got another topology. So we've got R1 configured with an IPv6 access list to deny FTP traffic to the 11 network over here. Okay. Ports for both FTP data and FTP control need to be blocked. All right. Because the filter is applied on inbound G00 interface on R1, only traffic from the 10 network will be denied. All right. So let's take a look at what they're doing down here. So we've got no FTP to this 11 network. Trying to deny any FTP traffic to the 11 network. All right. So we're going to deny TCP from any source to the destination network of 11 FTP. Okay, so no FTP from any network to 11. And again, no FTP data from any network to that 11 network. All right. We're going to permit anything else, IPv6, any. So anything else we're going to permit. All right. Then we're going to go to R1, G00, and apply that on the inbound interface. Let's take a look at which interface that was. R1, G00, inbound. Okay. So if that does happen, only traffic from this 10 network is going to be denied. Kind of like the way that's worded in the slide we just saw, because it makes it sound like you don't want any FTP to get to this 11 network over here. And if that were the case, you'd do an outbound from G01, but whatever, we'll just listen to what they told us to do. We're not really listening to the extended versus named rules here in IPv6, I guess, in their presentation. But you still do follow the extended rules in IPv6. You're still trying to kill traffic as quickly as you can to make your network run more efficiently. But these examples don't seem to be doing so. Okay. We got some more examples. I think I might just kind of skip through this because we've seen plenty of examples. All right, verifying ACLs, show IPv6 interface G00. You can verify you've got an input feature access list. The inbound access list is restricted access. Show access lists. You got your permits, your denies there. Okay. The IPv6, their sequence number is going to come at the end, so that's a little different. that you see there. Okay, so before in IPv4 you had the number out in front. In IPv6 you've got the sequence number at the end. Okay. When you do your running config, you're not going to see the sequence numbers at all. So don't be surprised in IPv6, do your show run, you're not going to see any sequence numbers on your permit, remark, and deny entries or your access control entries. So we got troubleshooting. There could be a lot of troubleshooting in access control lists. So your inbound ACL logic, you're only going to check the against the access control list until a match is found. So if you find a first match and that match is a deny, packet's discarded right away. It doesn't move on to the second match. If you find the first match and the packet's permitted, it's permitted right away. It doesn't move on to the second match. Doesn't care. Okay, so be aware of that. If you do a deny a huge range of networks first off, and then you try to add a network within that range later, your packet it's never going to check against that second entry. So you kind of want your more specific network statements down to your more broad to go from first to last. Your more specific network statements first, your more broad network statements later. Okay, because as soon as it finds a match, it's going to permit or deny that traffic. Okay. Outbound, same thing. Same thing. All right, this is basically saying what I just said. It checks against if it's permitted or denied. If it matches, then it goes through. It's routed if it's on an inbound interface or an inbound ACL. If it's an outbound, it'll just be passed on through to the next hop. So I'll just leave this on the screen for a second. Really, this is what we just discussed. And away we go. Trying to keep it under an hour. We're at 47 minutes. So let's troubleshoot this guy. 1010 has no telnet connectivity with 3012. So over here, 1010 has no. Okay. So we've got to deny any, and then we tried to permit telnet after that. So that's just what we discussed. If you deny all traffic first, then you try to permit some protocol down here afterwards. It doesn't care. It's going to go ahead and deny based on this top statement and not ever get to this bottom statement. So you'd want to reverse these. That's your mistake. You need the permit up top, the deny down below. Okay. That would be what you're looking for. All right. So that's where this entry went wrong. All right. 10 cannot use TFTP to connect to 30. So 10, 0 here, 30 is there. What is the problem? Let's see. We're denying. Let's see. TFTP is not TCP. That's why. TFTP is UDP. So if you want to cover TFTP, cover TCP and UDP, you'd want to put permit IP any, and you would be good to go there. So that is our issue here. What else do we have? Telnet should not be allowed. Well, you know what? I'm just going to go through these. You have these in your readings, so you can check them out. These are essentially just going to be a matter of digging through your access control list, figuring out if it's placed the wrong way, if things are in the wrong order, fixing the order, doing what you need to do. There is one example I might want to take a look at if it's in the slides. Give me 1 second here. This is the one. So for your sequence numbers in IPv6, if you need to replace something in the sequence. For instance, I believe this is the one that's going to be replaced. All you've got to say is no permit blah 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 sequence this. So if you take a look here, we've got to remove this entry. We just say no that, and no blah blah blah. You don't write the sequence number when you say no. Okay, you're just removing them. And then after you remove them, you're just going to place them back in the correct order, and a sequence number will be assigned. So you're not actually typing in the sequence numbers like you would in IPv4. You're just removing the ones that shouldn't be there, then adding them back in again. Okay. So as you can see, you aren't writing the sequence numbers out there. All right. So remember that. That's how it goes in IPv6. You don't write the sequence numbers. You just remove and re-add things in the sequence you want. All right. Anything else? I think that's going to be it. I mean, everything else, like I said, troubleshooting is a matter of analyzing your access control list and then going from there. So that's going to end this video. It's a longer one. It's a little bit of review, but the extended access control lists are pretty new. We did not discuss those in CCNA 2. So plan on getting probably chapter 5 done by this Saturday. We'll see. Hopefully we get there. All right. Till next time.